Hello guys, hello everyone, hello Zimbabwe, Africa, everyone around the world. What's up guys? Hope you are fixing things wherever you are. So today we have this job. This job is coming from one of customers, but you know there's a story behind this. It came like this. I didn't open anything. It came in pieces. This is coming from a young boy who is still at school doing Form 4. You know, young boys, they love experimenting. So he was explaining to me what really transpired, because I was eager to know why this laptop is not turning on. Because he said I was using the laptop. When I was using the laptop, the charger stopped working, and I tried to do something. And you know what? I asked him, what is that something? I don't know how to explain this, but I'll show you. You see this? Let me do this, because I want you to see. This is the AC power adapter. So he found out that the power pack is no longer working. He cutted the thing and it comes straight like this. He put this the top of the Lenovo laptop. This is Lenovo Lenovo G40. He cut the AC cable. He cut the head of the laptop charger. He plug it like this, and he injected direct AC into the motherboard. You know, yeah, those are childhood mistakes, but I don't think you can do something like that. So basically there's nothing to fix here, but we just want to check how many damages, or how the motherboard can, how far the motherboard can be damaged if we inject AC direct without putting the power pack. You put 220, 220, 230. So it's pretty bad. That's a stupid mistake that he did. I think the idea of this video is just to see what kind of damages that we will see on a motherboard after you have done such a stupid thing. You can't bypass the power pack, because the power pack is there to change from AC to DC. It's changing from 220, 230 to 19 volts DC. Like Lenovo, they are using like 20 volts DC, and you come direct with the AC. I don't think there's anything which is still working here, but we'll check. Because from that moment when he explained to me something like that, I said, you know what, the best way that I shall do for you is to look for another motherboard. There's nothing to fix there. You have done the worst mistake ever. So let's see what do we have here. We have this motherboard. It's for Lenovo G40, and what I want to do, let's put our multimeter on diode mode. Here we have the charging port here. That the charging port is coming here. After the charging port, we have this brown thing, that the fuse. Maybe you can't see. Maybe you can't see. We have a fuse there. We have a fuse, first MOSFET, second MOSFET in serial mode. That the current sensor white thing, and from there the 19 volts is going everywhere. So what I want to do, we just want to see the kind of damages that we have. First of all, obvious, I'll check the fuse. Next to the charging port, and the fuse is gone. You see, the fuse must be like this. There's no beeping, so this fuse is gone. The fuse is gone. The next step, I'll put one probe to the ground, and I'll check on the input of the first MOSFET. It's not ground. On the output, the output of the first MOSFET is 0, 0. The main 19 volts power rail is shorted. So now you understand why this fuse is blown up. Okay. So we have a dead fuse. We have a short to ground on the main power rail, on the 19 volts power rail. Let's come with the power supply. Power supply is set on 17.5, around 4.4. Let's lower the current to around 3 amps is okay. I'll come on the current sensor. Voltage drop to 1.8 volts and is taking maximum current, which is 3 amps. And what is shorted? What is taking that 3 amps? What is on the other side of the board? Oh, we have the ENE, some components. Okay. So I just want to see what is shorted, what is taking that 3 amps. What is taking that 3 amps? No, it's not the EC chip, because the EC chip is here on the other side of the board. It's called and what do you think is drawing that current? What is drawing 3 amps is the processor under the heatsink. So this processor is gone, but we check further. What I want to do, of course, we are not fixing anything here, but we just want to see how far the 220 230 AC 220 230 AC can damage the motherboard. So the first thing, we're just learning. It's good to learn so that we won't do, so that anyone won't do such kind of mistake. The first thing, fault number 1, we have a blown up fuse. Fuse blown up. The fuse is blown up. This fuse is blown up. Second thing, what did we see by now? We have seen that the main 19 volts power rail is shorted to ground, and if I am to inject 19 volts on the current sensor, the CPU is getting hot. So most likely we have a dead CPU. We have a dead CPU, but we have to confirm that. So if I'm to inject, maybe I can raise the current. Okay, current sensor. The heat sink is getting very hot. So obvious, what is under the heat sink is the processor. Both these are kind of motherboard with everything soldered on one chipset. We have processor, we have graphics, the Intel graphics, we have the PCH, all in one. So for sure, the CPU is dead. CPU is dead. So what I want to check first is to check again. I want to check for multimeter is still on diode mode. Let's check to resistance of each and every coil to ground. What resistance do we have here? Here, I believe the charging circuit is not shorted to ground. Here we have this power supply which is next to the RAM. I believe this is the RAM power supply, and is 0 0. You see, is 0 0. So the RAM power supply is shorted to ground. Okay. Here we have two coils. These coils, one is for 3.3 and one is for 5 volts. This is the 5 volts power supply and the 3.3 volts power supply. I think if there's someone who is fixing laptops, you can confirm the 3.3 and 5 volts power supply based on experience. So let's check to ground. 0 0. So the 3.3 and 3.3 volts power supply and 5 volts power supply, all these coils, they are shorted to ground. The RAM power supply is shorted to ground. What do you have here? Here we have another coil with 0 resistance. Even the CPU, we have a very low resistance on the CPU power line, the vehicle socket, but should not be like 0 resistance. That's not good. So even on this power supply, which is showing like 3 ohms, we have a problem there. We have another coil here, 0 again. Maybe it's for the processor and the processor and graphic power supply. So okay, let's write down 1.5 volts power supply is shorted. This is what happened if you inject AC direct into the laptop, like what this young boy did. The 1.5 volts power supply is shorted for the RAM, that's the RAM voltage, and 3.3 volts and 5 volts power supply, we have a short there. We have a short there, and this cause for the processor, the CPU, is showing like 3 ohms. I don't think that is normal. Processor maybe is 1.2 volts, and we have 1 volts for graphics. Is shorted. So to confirm that all these power supply are shorted, I will lower my DC power supply to 1 volt. Let's set exactly to 1 volt. Yes, 1 volt. I'll check this on the RAM. You can see with 1 volt is taking 2.7 amps. Yeah, here we have the driver. The driver is getting hot. The RAM is not like hot, but it's very warm. So with 1 volt here on this 3.3 and 5 volts power line, it's taking 1.7 amps. Let me see my microcontroller. No, the microcontroller is not getting hot. Here, obviously here we have like a coil, and we have the controller with MOSFETs inside. Obvious, these controllers, they are all gone. They are all gone. What I would do, we have this MOSFET like a, we have this BIOS like a MOSFET, a big thing. I'll check on pin number 8 of the EEPROM or BIOS. I see pin number 8, pin number 4 is ground, pin number 8 should not be grounded, and pin number 8 you have 0. And this is this kind of BIOS, not BIOS for the EC chip, for the ENE. This is a kind of BIOS for the PCH inside the processor, and pin number 8 is shorted to ground. So we don't know if this is a 1.8 volts BIOS or a 3.3, but we'll use lower voltage 1.78, and we'll go on the pin number 8. It's taking 3.3, and this thing is getting warm because the PCH is shorted. Okay, So processor is gone. Obviously the PCH is gone because it's together with the processor. Let's ignore those coils. Let's concentrate on the ENE. We need to see if this ENE is still alive or not. I told you how to check on some videos that the ENE chip, this one, Lenovo, I'm checking on the capacitors around the ENE chip, because one side should be grounded and the other one should be connected to 3.3 volts always on, because from the plus of this capacitor is taking power from VREC 3 and is always under the power even if the motherboard or even if the laptop is off. So I'll check ceramic capacitors around the ENE chip. This one is shorted. This one is shorted. The third one shorted. Like 5 capacitors which are shorted. We can use same voltage 1.8 and try to see what is taking that power. .3. This is ground and this is plus. I can't feel any heat. Yeah, it's getting warm. It's getting warm. So, logical speaking, if you have done such kind of thing, there's no way the ENE chip will remain alive. So, this chip is dead. Let's go with 3.3. Well, those capacitors, they are meant to work with 3.3. Yeah. The ENE is shorted. So, you know, based on the age of the guy, I understand, because I don't think an adult person can do such kind of thing. You still at school, you still want to experiment things. So that's what will happen if you inject AC direct to a laptop. Here the 7th ENE chip is dead. So basically that's what we call general board failure. At this point you have to admit that this motherboard, there's nothing to fix here. We have to come to an agreement that this is the worst fault ever. So we didn't fix anything, but I just wanted you to see what I come across today. And yeah, the board is pretty damaged. So if you have done such a stupid thing, or if maybe, let's say you didn't do something like that, but your charger it happens that your charger can be faulty and send too much voltage to your motherboard. In most cases, it's very hard to bring back that board to life. It's very hard. In 90% of such kind of issues, you can't do anything. You can't. What do you think I would do here? What do you think I would do here, even if we will try to fix? Obviously, I will replace the fuse. I'll try to go power supply by power supply, replacing the driver, each and every power supply, replacing all those bent components, and the microcontroller, we can get another one. Well, this one is the new model, I believe, with BIOS inside. We can get another programmable EC chip, but you know where we get stuck? The processor, because this is the processor soldered on the board. Usually I'm not doing reballing because it's not worth here in Zimbabwe. People, they don't pay. So I did not bother myself trying to buy a BGA machine to replace those chips, because I'll be operating at a loss. People, they don't want to pay this side. So hopefully I'll get better jobs, and I will try to move on with our repairs. This is just the worst case I come across today, and yeah, it can happen, especially with these young boys. They don't want to experiment. Too much experiments. So like, subscribe, and share our videos to your friends, beloved. Also, after subscription, just turn on the notification so that you won't miss any updates in the future. See you on the next one. Bye.